I think this program took me about 15 hours. This is how the actual part will look.
Okay.
I'll show you. And then this is the stock setup. That's the billets that we use. We're going to cut it out of this. This is a simulation of what the tools will actually do. This body. I do the whole program, um, tell each tool exactly what to do and all that. So it takes quite some time.
Imagine.
So when you do have the program, you save it and you keep it. There's a lot of tool paths. Like here, this is called the tool path. You have to create each and every tool path from scratch. Look how many there is. I've been in this industry for 9 years. I would say around about 2 to 3 years, you get like a hang of it. You get experienced, you get used to the machining, the types of machining that you want to do. Yeah, but I learn every day. The training was about 2 years, just to know the basic stuff. But I think this industry is more of a hands-on experience, like you build experience over time and you learn as you go. A lot of places have on the job training, so I think that's very important and necessary. There's no way you can learn this in a class, get to a workplace environment, and you will be able to do everything. I think the scariest thing for me was kind of like the bigger the machine, the scarier it felt. So the first time working on this machine was like very scary because you feel like you have to check everything and everywhere.
Do you worry more about getting the part wrong, or do you worry more about damaging the machine?
Uh, Damaging the machine though, because you can always remake a part. But yeah, if you damage the machine, it's a lot of money to fix. You must just be vigilant and stay focused. Yeah, people grow quite fast because we give them opportunities to learn. She started from a cleaner and now she is a basic setter. She can do basic setups and all that. I would say 3 to 5 years, she'll be on a lacquer space where you can give her a job and leave her to do it herself.
After school, I went to the Army National Service for 2 years. And then LIW, division of the now Littleton Engineering Works, they were looking for apprentices. And that's where I started, got my training from LIW. In the interview, I wanted to do tool making. And they said to me, no, there's no tool making positions available. They are filled. Am I interested in what they call dryer met in begrip van machinering? And so I looked at him, George, and I said, no, thank you, not for me. So he says, why? I said, no, I can't see myself making bolts and nuts for the rest of my life. So these old two toppies, they were pissing themselves. So they stopped the interview and they said, walk with us. So they took me to the cannon factory where they used to make the G6 cannon barrel. and they showed me this barrel on this humongous lathe, and they showed me the process, and I was just stunned. I said, "Oh, what? I want to do this. I want to do this." So yeah, then I enrolled as a dryer met 'n begrip van masjineering, and yeah.
So you're like studying, and then the rest of it was in the factory.
Not studying, practical training, doing jobs inside in the appy shop. Our apprenticeship course is 3 years, 3 years and a few months. There was a lot of modules and aspects that we had to work through and master, get it under the knee, and okay, you're ready for the next phase. And then they put you in certain divisions inside the factory to get some practical experience. 7 o'clock we start, so you got to clock in about 5 to 7, not 7 o'clock. Don't pitch at work 7 o'clock on the dot. So every appy used to get a turn to read a sticky from the Bible and then say a short prayer, and that's how we start our day.
A lot of rituals.
Yeah, you can say that. A lot of rituals combined with a lot of discipline. I got moored more than once. I got thrown with spanners. My jobs were thrown out of the door if I made one little mistake. They were very strict. The standard was very high. It was good training, but it was hard training.
What did they make you do over and over again on the training?
The first section. Yeah, you get 2 blockies, 8 mil thick. And then you mark out a T in the blocky. And then you remove that section. And then on the other one, you've got to cut that T out. Now that is with a drill, ystersaag, a hacksaw, and a set of files. Then you've got to make the T fit into the cavity. And if there's air around anything more than 0.1, and this is how they do it. This is more or less 0.1, the thickness of this paper.
They use paper.
If your paper goes through, you plug, then you've got to do it over. I was allergic to files after the second weeks, but nobody got it right the first time. That was the first practical training job.
What was the most precise you ever had to be in training?
It's about 50 microns, doing a job within 50 microns, but that was quite a challenge because we used to do that on manual machines. If you want to move the cutting to, let's say, 0.1 forward, you put a clock on and you move at 0.1. Make sure you move 0.1. You cannot work on the dials of the machine because they're not true and accurate. I think they did it on purpose. They don't let the guys work on faultless new machines. They want to give you a challenge, want to see, have you managed the skills? Can you do the job? Can you think out of the box?
How long did it take you to get good?
I'd say after my 8th year at the NEL, I was quite confident. I would regard myself as not good, as good enough to do the job.
Wow.
Yeah. There's always room for growth and like everything, this is progressive growth. The more you do it, the better you become. There's so much to learn. This trade, you will never know everything.
Usually I'll just run it high RPM to see how is the centrifugal force and the machine doesn't shake or anything.
So do you just have to see that, or can the machine?
You can feel it. You can actually feel it. I'm old school. I'm still using a piece of paper.
How do they do it nowadays?
They have probes and everything. I see.
All sorted.
All set up, yeah.
Right.
This we call stiffening ribs. I did made a whole set as well that rolls out this whole
Yeah.
form. But this one puts in more ribs like this.
So this is actually for a machine.
Yeah.
What happens if one of these is wrong?
I try not to make a mistake, but sometimes something does happen.
Yeah.
Yeah, maybe we're lucky, maybe we can change the design, maybe the client will be happy. We never send something out the door that's wrong,
Ever.
ever. We'd rather buy the material, do it over again and make sure it's right. If I know a job is unfixable, I won't even try fixing it.
Is it?
Yeah.
Start again.
Start again.
At your own cost.
Sometimes, yeah, sometimes we're lucky.
To me, it's a very satisfactory. I mean, at the end, when you do a job and it's perfect, it's according to drawing, and it goes out that door, and the client comes and he says, "Thank you." It's not just a job. It is I can create something that can create a hell of a lot benefits to other people. Now, all of our components gets fitted into a next level of something, a next level of either a car, a machine, or this. And that next level of something is creating jobs for that group of people. that guy can make now money with his machine and he can employ people. But he depends on me. My parts needs to be correct. Otherwise, his assembly is not going to work. So his business is going to be a F up. You sure they're right? Nah. So what happens if the quality inspector comes and he picks up one, he measures and it's not according to specification?
They're gonna reject the whole order.
Because they will reject the whole bunch. This is the engineering Bible, is the drawing.